Good morning, all students. Welcome to the another session of Structural Analysis 2. I just came to know that a couple of you have arrived at the campus. That's a good sign. However, to come into the class and handling the offline lectures also, I need to prepare myself with some of the gadgets which I'm using here. So today it was not possible for me to do it. So probably after the break of these holidays, whenever the next session, I'm sure and definitely we will start our offline sessions also. So I advise all of you to start coming on the campus so that we can do this numerical based exercises with more exciting, and we can create good practice also. Because there is nothing like offline classes, and I understand completely that thing also. But for today, let's carry on with the largely the online session. And those who have come here, those who are there in the class, I advise them to connect themselves with the gadgets that is with them, so that you don't miss the contents and you can practice it being there in the classroom also. So I can see nearly half of the students of the total strength have joined. So let's wait for 1 or 2 minutes after this and we'll begin the session. And meanwhile, those who have joined, start entering your details in the chat box for the attendance purpose. All right, so friends, this is our 23rd session, continuous third session, 23rd session, and we have been discussing unit load method since last class. And in the earlier session, that was yesterday, I started discussion on how to use unit load method for beam analysis, as I made it specific that it has largely nothing to do with the energy principles. However, it's a versatile and very effective method of structural analysis, especially when you are concerned with the calculation of any of the properties like rotation, like let's say deflection, or even the reactions of the indeterminate structure. So it's a very versatile method which you can employ on any type of structure, including the planar structures are concerned. Right. For space structures, it requires a little bit of modification and may not be appropriate for the same. However, it's good to know that you are practicing, and I'm sure that most of you must have completed the work which I assigned to you in the last session, that you were required to complete the numerical which we left incomplete in the last session. So we started our calculation. This was the problem which I completely solved and demonstrated the use of the unit load method in the last class. And this is the second problem that we started and we left it incomplete. So before I go ahead, let me know how many of you have tried this. You can raise your hand in the chat box. I can unmute yourself. How many of you have tried this, completing this numerical? You can answer the question by raising your hand. So tell me, how many of you have tried this? I have noticed in some of the cases, there's a very poor response in the examination, right? And I'm very keen about it. I'm very particular about it, that I'm sure that it was because of your known practicing attitude, right? You should practice. You should write things in the notes when your teacher is delivering something which is numerical based. So numerical exercises cannot be read. And when you read a numerical, you don't learn anything, right? So unless you put things on paper, you calculate them, then only you gain the confidence. So that is why I'm insisting that how many of you have made an effort to calculate this numerical. However, most of the work is completed for this numerical. We started analyzing this cantilever beam for calculating the deflection at point C and rotation at point C. And you can see that we have already generated generalized moment equations for all the segments, considering all the loads individually. Now, which are the loads? The first load is the externally applied load, because of which we get to know our first most important equation due to capital M here, right? You watch the movement on the slides of my digital pen. I'm using it here. So because of 50 kilonewton load and 15 kilonewton load, we have developed this equation for first segment and second segment altogether. And consecutively, we developed the generalized equation for unit load at point C, because we are interested to find deflection at point C. So as a rule of the method of unit load, you must have a unit load applied at the same point where we are interested to find the deflection. And in case of the rotation at the same point, you need to apply it unit rotational movement or moment, right? So M1 is nothing but the generalized equation induced in the member itself due to the application of unit moment. Here I have demonstrated it. You can see here. Let me change the color for a while just to indicate. Here you can see we have applied unit load at point C just to obtain the deflection, and here we have applied unit moment just to develop generalized moment equation M1, and we have rightly written it. So now it's just a matter of collecting the information together. So first we'll try to obtain delta C. We need to flip between the sinks slides. Delta C can be obtained like this, 1 upon EI segment wise. The first segment was 0 to 2 meter and second was 0 to 4. So 0 to 2 meters we'll write here. Now M into M, small m, dx, plus 1 upon 2EI. We'll not forget it, because we have been given this data in our equation, capital M, in the problem, small m dx. All right, so let's say delta C equals to 1 upon EI. We'll keep it as it is as of now, 0 to 2 meters. What is capital M? Minus 50. So we'll write down minus 50 should be x. Yes, minus 50x into 0, because there is no other unit load associated. 1 upon 2 EI, 0 to 4 meters. Please keep doing the things with me. Everyone, whether you are offline, online, wherever you are, keep calculating the things with me, so that only you will gain the confidence. Minus 50x plus 2, right? So minus 50x plus 2, that is due to the point load, and minus 15 times x squared by 2. And then we have small m, let's check it, minus x. So that is negative x here, dx. That's all. That's it. So If we take this negative sign out of this bracket, it will get positive, negative, negative become positive. So let's rewrite and rearrange these things together and let's try to obtain the final answer. We will avoid this term because it consists 0 here, so it will become 0 itself. So we'll avoid it completely. EI 0 to 4. Now our rearranged equation becomes 50 times. Let it be repetition. Let it be a repetition of writing the same values, but you should learn step by step, because that's what I've noticed, that you are unable to solve numericals in the exam. So that was a big setback for me also, so that somewhere I'm also not being able to deliver the right contents. That's what I believe. But anyways, let's improve it. So x to be multiplied with each of this content. Now before that, let's expand this 50x and 2. So we can open it now. 50x plus 100. Is it okay? Plus 15x squared by 2. And still we'll keep x here, dx. And now it's the right time to go ahead with final calculation, nearly final calculation before integration, which will give us the complete state of the equation. Sorry, 50 x square. I'm going slow little bit off because I want you to understand everything clearly, how it works, how it is being done. And now we are ready to integrate, right? So 1 upon 2 EI. Now let's integrate it. 50x cube upon 3, right, plus 100x squared by 2 plus 15x raised to 4 by 8. Limit of integration is 0 to 4 meter. So now it's a matter of employing the value here. Delta C is equal to what? Who will give me the expression in terms of numerator and denominator as EI? You work upon that and tell me the answer. Darsha is there? Yes, Darsha?
Sir, I am getting 1173.33.
1173 point. Come again. 1173 point. I'm just writing your answer. I'm not confirming it because let other people work upon this. But you can tell me the complete answer here. Also, in parallel, let me check it. 4 cube 250 by 3. 4 cube 250 by 3 is okay. Let's cross check. This gives you 1066.67. Is it okay? Then we have 4 square into 100 divided by 2. So it gives you 800. Right. This is 800. And then we have 4 raised to 4 into 15 divided by 8. So that gives you 480. So let's sum them up. 1066.67 plus 800 plus 480. So that is 2346.67. Is there anything wrong over there, Darsha? Or is there any mistake? Anyone getting this answer? You can raise your hand. 2346.67. Is it correct? Please check. Those who are getting this answer, raise your hand. Somebody has raised. Prashant. Yes, Prashant.
Sir, you forget to divide by 2, sir.
All right. So it is still in this form. So there is 1173.33. So earlier Darsha was correct, I suppose. 117.
Yes, sir.
3, 4. Okay. Divided by EI. Kilonewton into meter cube. So now it's a right time to employ the rest of the values. 1173.34. 12 divided by 6 to the power 13. So let's divide it further. So it is 195.5. So it is 19. Is it okay? 19.5. I hope people are getting the answers like this. Raise your hands. So that we can confirm this answer. Birendra. Birendra, you can unmute yourself. Or Prashant.
Yes, sir. Yes, sir.
Yes,
I
please.
got 19.5.
Very good.
Yes, sir. Same, sir. 19.5.
Same, Prashant also. Okay. So let's go ahead, friends. And now I think you should be in a position to obtain theta C very easily. So I'll be giving it to you. Should I start here? Because otherwise we need to write a lot of things on the other page. But anyways, it doesn't matter. Uh, let me draw it again and let me show you how to develop that particular equation completely. This is just for your reference, and those who have already done it, there is no need to repeat the table. However, let me simply write down it here 15, and here you have 50, right? This is 4 meter, this is 2 meter, this is 2i, don't forget it. This is I. So let's write down theta C equation over here. 1 upon EI, that is for first segment, 0 to 2. Capital M, small m1. Don't forget to include m1 now in the picture, right? So we'll write down 1 upon 2 EI, and give me a moment. I need to communicate with someone. So I'll be coming back within a moment. All right. So let's carry on with the inclusion of the values. Let's see. 0 to 2. What is capital M? It was minus 50x. I still remember. And M1, let's see. Oh, that's 0. So we'll keep it 0 here. Dx. So in a way, you are getting a benefit of reduced value also. 0 to 4. Here it was minus 50x plus 2 minus 15 x square by 2 was the capital M, and here I suppose it is negative 1 dx. If I'm not wrong, let's see. Sorry. Yes, it is. See here, minus 1, right? So that you have to include here, and now it's all simple, so simple and straightforward. 1 upon 2ei, because we can avoid this since we have 0 here. So first term is avoided, 0 to 4. one by one. So negative negative gets cancelled each other, cancels each other. So 50x plus 2 minus plus 15 x square by 2 dx. That's it. That's the story. So let's expand. Let's integrate now. 2ei. Let's expand this 50x plus 100 as usual, plus 15x square dx. We cannot still integrate it because we expanded it. So we'll write here 0 to 4. Don't mind. This is integration sign only. So theta c, let's write down. Now we can integrate it. Yes, 1 upon ei 50x square by 2 plus 100x plus 15 times x cube upon 6. Limit of integration is 0 to 4. So now you can share your answer with me in terms of ei in numerator, denominator, and give me the answer of numerator. Oh, I can see Deep the way. Okay. Yes, Deep.
So I am getting 480 by EI.
480 upon ei. That's it. Okay, let's confirm with someone else. Okay. Yes, Darsha. Is it okay?
Yes, sir. Same.
Let's go to Prashant. Yes, Prashant.
Yes, sir. Same, sir.
All right, so just carry on. Do not forget, friends, that 480 should be multiplied with 10 to the power 9, right? And this is 6 to the power 13, right? So now we know what to do, what not to do. So 480 divided by 6, that is 80, divided by 1, 2, 3, 4, 5. So it's 8 raised to the power minus 4. 8 to the power minus 4 radian, that is your rotation. For a rotation, it's a sensible amount, I would say, because the loading is very high, as well as the length of the unsupported member is very high. Like for a cantilever, 6 meter length is very, very high length, right? So that's why we are getting such a huge amount. Also in terms of deflection, that was nearly 20 mm, so that is 2 centimeter. In real field or real application of the structures, this is considered as a very, very large amount of deflection. Please understand, right? Okay, anyways, so let's go to the another numerical. I'm sure that most of us are clear how to use unit load. That's what I assume and presume. I take it for granted. Let me take one more numerical on this, and then we'll go ahead. Now this time the change is you need to explain all the procedure here one by one, and especially those who don't raise their hands during the overall procedure. So I insist that you should have that practice doing it. So let me take another numerical. So that is here. Let me draw it first completely. I don't want to rush unnecessarily. That's why I'm repeating the nature of the numerical here. Again, it's a tapered section. So it's nearly like this. This is 3 meter. This is 2 meter. But I'll be changing the loading so that we can get another problem. Let's keep it 100 kilonewton. And the UDL is of, let's say, 30 kilonewton. So there is a significant amount of point load which is concentrated over here, right? And now we need to obtain deflection at point B and slope at point C at different locations. Please understand. Let's write down A, B, and C. Please maintain this nomenclatures or indication of the points, just what I have made, because to have a common answer. Now what we require deflection at point B and a rotation at point C. So how do we start? I have already explained to you that whenever you are in need of deflection, you need to apply unit load at that location. So unit load will be applied at point B. This is your first unit load application, and second will be somewhere here. Second would be somewhere here, where you need to apply unit moment. This is 3 meters, this is 2 meters, this is 5 meters. So I'm sure that you are well aware about how to handle them one by one. This unit load will give you generalized moment equation for M, it will be indicated by small m, and generalized equation developed due to the application of the unit moment will be indicated by M1. Okay, friends, so now you just need to guide me, and according to your guidance, I will start the calculation. And needless to add that due to the external load, the moment equation that will be generated, that will be indicated by capital M itself. Okay. So it is very obvious that we have two segments in this beam, B2C and C2A. So let me write it down. B being the origin, BC being the segment, right? Now, what's next? The length, of course, 0 to 2 meters. And now the M equation, first of all. This is a first stage, first step, whatever you want to write, it's up to you. So somebody has to guide me how to write equation of capital M for segment BC due to the external load. Who will do it? Assume that, yeah, I know, Prashant, Darsha, then the couple of more students, those who are usually answering and responding, I appreciate completely, but let's give chance to somebody else also. You have to start with X distance, and then if nothing happens, then I'll come back to you. So let me ask randomly now in this case. Somebody has to answer. So let me ask. This is a way in which you will be responding to me. At least you can try. There's nothing wrong over there. Ankit, you can unmute yourself and just have a dialogue with me. I have unmuted you, Ankit. Where are you? Ankit is here. Ask him to unmute. I have asked you to unmute yourself. Just unmute yourself, nothing else. I'm not asking for a solution. I just want to listen to your voice. Yes, Ankit.
Yes, sir.
Okay. Okay, Ankit, would you like to help us in writing this equation? I'm asking you to help us in writing the equation for segment B to C, okay? And the loading is UDL, that is 30 kilonewton per running meter. And distance is X, not 2 meter. So how we take moment in this case?
C to B. B to C.
Yes, try B to C, okay? So what is the load? Let me ask you some questions. It will give you the solution. Okay, tell me what is the value of the load first of all?
30 kilonewton.
30. So let me write 30. Okay. just as it is. Okay. Now, how we take moment for a UDL, Ankit? Force into distance.
2.
Okay, so see, now here you understand that we are right now not concerned with full length. Okay, we
Okay.
are
1
concerned with
meter.
X only, Ankit. Okay,
Yes, sir.
so first of all, it is required to convert UDL into total load. So total load will be converted by multiplying with the effective length. Now here, what is the effective length? X. Okay.
Yes.
So first total load we have converted, that is 13 to X. And then you have to take moment at the center of that length. Are you getting it? Right?
Yes, sir.
So where will be the center of X?
X by 2.
That's it. So again, if I multiply X by 2, so it becomes X square by 2. Yes or no?
Yes, sir.
That's it. So that's what you want to calculate, right? And this moment of this force is being considered clockwise. Okay. So
Yes, sir.
we will put it negative.
Okay. Negative.
Don't worry about background voices. Don't worry. Just focus on this. So this is negative 13 to X square by 2. Are you agree with this, Ankit?
Yes, sir.
Okay, excellent. So see how wonderfully you have developed it. You did it. I didn't do it, right? So that is the benefit of communicating, and you can also solve your doubts also. Okay.
Yes, sir. Yes, sir.
So now, okay, now you can mute yourself and let me go to somebody else for helping me in development of small m equation. So let me check who is there. I can see many of you, of course. Vivek is there. Vivek, you can.
Yes, sir.
Yes, Vivek. So you can unmute yourself. You have unmuted. Now, Vivek, let's help us. You just help us writing the equation for segment B to C with unit load. How can we write? Because see, this is our point of interest. Okay. And this is the X length. So I have a force, I have a distance. So can I take moment, Vivek?
Yes, sir.
So how do I take it? Like 1 is the force, you understand? 1 is the force value, okay? And multiplied with what is the distance?
X.
X, that's all. So force is considered, distance is also considered, and it will create again which type of moment? Clockwise moment?
Yes, sir.
So should I put negative here, Vivek?
No, sir.
We consider clockwise moment as negative, right? It is our
Yes, sir.
way long understanding that we consider clockwise moment negative and anti-clockwise moment positive.
Positive.
Please remember this, okay?
Yes, sir.
So that's why, yeah. So that's why now you helped us to write the equation like this. So now it is correct. So thank you, Vivek, for being with us. And now let's write down one more equation. You can mute yourself, Vivek, so that we can give chance to someone else. So it's working, I think, right? Working like this or asking questions individually, it's working, right? So M1, who will help me now? Now I expect some volunteer from other students. Like it's working. So who will tell me? Shaban, you can unmute yourself. Are you there, Shaban?
Yes, sir.
Yes. So what should I write here? According to you, see now you just focus here. This is the condition. Here is your externally applied moment. And I'm asking you to help us to write down the equation for this segment. Is there any force in this, Shaban?
No, there's no force, sir.
No force. So what should I put here?
0.
0. That's all. That's all. That's all. Thank you. So this is how we collectively work together. And thank you all for interacting with me on my request. So again, let's go for the second segment. The origin will be C. The segment will be C to A, right? 0 to 3 meter will be the distance. And now, how should I write M equation, capital M equation? Now, where should I go? To whom should I ask for help? Okay, Dharmesh, are you there? Dharmesh, don't worry. I'm here with you. Collectively, together we will teach to the rest of the class. So just unmute yourself. Dharmesh, are you there, dear? Probably is not there. I can see him. I have asked you to unmute yourself, Dharmesh. Are you there? Still one more chance. We'll take with Dharmesh. Dharmesh, you can unmute yourself if you can hear me. Don't worry if you don't know the equation. Don't worry at all. That's why I'm here. Together we can do it. But don't worry about anything. Just unmute yourself once. Okay. Then should I go to Ravi then? Ravi, are you there?
Yes, sir.
Okay, so Ravi is with us now, and together we'll create the equation, Ravi. So you know what we have to do, right? We are trying to write down the moment equation for second phase, that is C to A, right?
Yes.
And that is also due to the externally applied force. So let's inspect this, Ravi. Don't mute yourself. Keep yourself unmuted until we create this equation. So this is what I'm doing for you only, Ravi, exclusively. So this is 30 load, right? And we are here actually. Are you getting my point? This is the X distance, Ravi.
Yes.
So now you tell me, how should I take moment of this force at this point? What should I do? Can you suggest anything? Like, first of all, we need to convert this in total load, yes or no?
Yes, sir.
30 into how much? 2 meters. Now we will consider full length, right? This full length is 2 meters, okay? So we have taken moment and now the distance. Now we have to consider total distance, Ravi.
Yes, sir.
So tell me what would be the total distance?
Sir, x plus 2.
That's it. Or we can write 2 plus x, whatever, like x plus 2. Let's go with Ravi. So this is what is the first moment. That's all. So we'll write it here. Minus, let's say 60. I'll write down 30 into 2. That is 60 into x plus 2. Is it okay, Ravi?
Yes, sir.
Okay.
Yes, sir.
Yes. Okay. Now let's inspect. Is there any other force left? So 100 kilonewton is waiting for us, and this is the distance, right, Ravi?
Yes, sir.
Okay, so we will write down another moment. Tell me what will be the moment.
Sir, 100 into x. Sir.
That's it, 100 into x. That's all. The story ends over here for this. Okay, so how wonderfully you have guided us. So that's fine. Thank you, Ravi. And now let's go for the another equation for second segment, that is unit load applied at point B. So now it's up to you. Become a volunteer, raise your hand. We can quickly complete it. Raise your hand. Those who want to respond, Prashant. Yes, Prashant.
Sir, for M, sir.
Sorry.
Sir, for M, minus 60 x plus 1 or x plus 2, sir.
Minus 1 into.
No, sir. For big M, sir, moment.
Yes.
For CA moment, sir.
For C2A moment, that is, you want to correct something?
Yes, sir. Minus 60 times x plus 1, sir.
Why x plus 1?
Sir, because the UDL distance is 2 meters and we should take it.
Yes, that's the point you have mentioned over here. This is
Yes.
what you want to say, right?
Yes, sir.
Okay, excellent, Prashant. So that is to be
Thank you,
included. Right, very good, very good. So this is what I want as a involvement in the class. So let me write down once again. So Ravi, you and me need to learn, right? Okay, x plus 1. Because it is already acting in the middle of this length, that is 1 meter, and here it will be x, so that is x. Okay, that's fine. Okay, so now Prashant, you continue. Unmute yourself. Tell me about small m. How do we do it? You can unmute yourself.
sir. For M1 or M?
For small m.
Minus 1 time x.
No, we are in a second segment. We are targeting second segment. So x is here. X is here now. Force is here. X is here. So this 2 meter. Could you consider?
X plus 2.
Yes, that's all. X plus 2. And parallelly, you can suggest M1 also. No problem.
Minus 1.
Minus 1. Why minus 1? Because you have the only option, that is M, that is lying in this segment, and it is to be considered, and it is clockwise, so it is -1.
Yes.
So I think, yes, okay, Prashant. So now I think by and large we are clear, the entire class, all 21 of us. I can see that many of you, discontinued this class. The moment I started asking personally, please don't do it. There's no need to do these things, right? You be with me, you be with others, and there's nothing to lose in answering the questions from my side. So see how wonderfully somebody has corrected us. So it's again amazing experience, So that is what we need to learn from the working with each other, and that's what we do in classroom also. So I advise that those who have already joined, please come back in the class, right? So that you are going to lose some important things, which I don't want you to lose. Okay. Okay. So now let's put the values together. First job is to find out the delta B. So let's do it. Let's put the equation first of all. Should we go for next page? Let's do it here. Try to do it here. Delta B. First segment 1 upon EI. That is the length 0 to 2 meters. All right. Capital M into small m dx. It's very straightforward. Now I think you don't need my any of the input over here. 0 to 3 meters, capital M into small m dx. That's all. So we'll put everything together. 1 upon EI. Don't mind, I'm using this space forcefully. Capital M is a minus, let's say minus 15x squared. Keep it simple. Minus 15x squared. I think it's okay. It should be okay with you. Negative x dx. Right? And plus 1 upon 2ei For second segment, 0 to 3 meters is the length. Now here it will be a little long equation, x plus 1 minus 100x into minus x plus 2. Oh my God, we are going out of the boundary. Okay, let's come back here. This is delta B. Please don't mind. I'm writing here. Let's simplify it, right? EI. 0 to 2 meters is there. So the term becomes positive and 15x cube. Right? Be careful when you are expanding the equations because that is the turning point usually in the numerical. 0 to 3 meters is there. And now let's try to remove the negative signs. So, and also let me expand this 60x plus 60, everything becomes positive. So it is 100x again on this side into x plus 2. We can still further simplify this by adding this 160. So it becomes 160 so that the multiplication becomes very easy in that at the end of the day. So now we are forced to change the page. Delta B equals to, okay, we need to go back 1 upon EI, right? 0 to 2 meters is the segment length. If I'm not wrong, it is 15x cube. Let me confirm it. Yes, it is 15x cube dx plus, I can see further reduction in the people. Only 20 students are there right now. Don't do it. It's not a good practice. Come back, all of you, those who have earlier joined in the class. Okay, now let's simplify this like 160 and 60, right? So 160 x plus 60 into x plus 2. Let me confirm it once again. It is x plus 2, yes. So now we are independent of the other page. So again, we'll wait for further expansion. As I said, I'm going very slow today because I want you, everyone actually, to do this comfortably. Those who are still facing challenges in the primary calculations, because everybody should get benefited. 160x square plus 320x plus 60x again plus 120. So if I'm not wrong, we have expanded it. Okay. Again, we need to write down 0 to 2, 15x cube dx, because there are few chances to further simplify this equation. 0 to 3 meters, 160x square plus 380x, right, plus 120 dx. Is it okay? Any suggestions? Or how many of you are getting the same equation? Become a volunteer. Confirm this. Anyone? Any one of you quickly? Okay. Yes, Prashant.
Yes, sir.
Okay.
Same, sir.
Okay, good. So now let's carry on. Now I'm full confident about the calculation since Prashant has agreed with us. So 15. Now let's integrate this. 4. Okay. 1 upon 2 EI. Sorry, I forgot to mention the limits over here. 0 to 2 is the limit. 160 raised to cube upon 3. I'm sure most of you have reached to the final answer also by this time, and you are ready with your answers. So get ready with your answers. Very soon I'm going to ask you, but rest of you all, please write down this carefully. Limit is 0 to 3 meters. So should I now expect delta B as in form of like this? Okay, so yes, Prashant.
So 1815 upon EI.
Sorry,
1815.
1815. That's it.
Yes, sir.
Okay, let's reconfirm it once, Darsha.
Yes, sir. 1815.
All right, anyone else from the class would like to confirm it once? Anyone else? Birendra. Yes, Birendra. Yes, Birendra.
Yes, sir.
Oh,
1815.
great. So should it be fine with all of rest of you? And now let me give, I think I have not given you the EI value. So you can take it as the old value, like 1815 10 to the power 12 divided by 6 upon 6 into 10 to the power 13. So give me the final answer now. So that is 1815 divided by 6, and it is 30.25, right? So that is what is the 30.20 yes, 30.25 mm. Okay, so should be acceptable largely. Now let's go to the next target, that is rotation at point C. Yes, delta C, sorry, theta C. So let's write down theta C here on a new page itself. 1 upon EI, 0 to first segment is 2 meters. Yes, 0 to 2 meters, capital M into small m1 dx plus 1 upon 2 EI. The length is 0 to 3 meters, capital M small m1 into dx. Now this time this final answer will be expected from the rest of the students first of all, and then we'll go back to our the other students. So m, let's go back, minus 15 x square. So it is minus 15 x square into m1. Oh, there is a good news. M1 is 0. So you can put it here. Okay, then let's go for it because it reduces your calculation. That's why in exam you'll get benefit. Now capital M, how should we write? Okay, so again negative 60 into x plus 1 minus what should be there else, 100x, that is capital M, and M1, what is that? Oh, minus 1 only. So let's go to that. That is also added advantage, I would say, as far as the numerical simplification is concerned. So 1 upon EI, 0 to 3 meters. Again, minus, I mean negative signs will get cancelled. So 60x plus 60, I'm parallelly expanding it, plus 100x. That's it, a very small expression. I'm sure that by this time most of you must have completed this also. 0 to 3, here it is 160x plus 60 dx. So now we can happily integrate it. 1 upon 2 ei still 160x square by 2 plus 160, sorry, only 60, right? 60 into x, limit is 0 to 3. Now work upon it and give me the, or you can give me the final answer also, I don't mind. In form of 10 to the power 4, you can give me your answer also, or whatever you want to share. Yes, Prashant.
Sir, 450 upon EI.
450 upon EI. 450 upon EI.
Yes, sir.
All right. So let's confirm, or you can give us the other answer also. 450 divided by 6. 10 to the power 9, 10 to the power 13. So it is 450 divided by 6, that is 75.
7.5 into 10 raised to 3 minus 3.
7.5 into 10 to the power minus 3 radians. Okay. So I hope Birendra is there. Yes, Birendra?
Yes, sir. Same answer.
Same answer. Very good. Excellent. So friends, I think largely we are clear with the application of unit load method. I insist, I advise all of you to start comparing the variety of the methods together. Take one common numerical, take one simple numerical, just like this, just like this, just like this, and try, let's say A, B, and C. I just want to give you an idea that how to compare the methods. You have plenty of methods to determine the value of theta C now in your pocket. You have many methods together, right? So apply them one by one, like 1, 2, 3, whatever methods you know, you apply them one by one and try to compare the answers. Answer will be same by and large, because the final answer has to be common. So delta C will be, the answer will be same, but the method will be different. And try to understand which method gives you more comfortability or which method takes less time. And in exam, if unless you are not specified to use a particular method, you can utilize this exercise at that time, because nobody can stop at that time that which method you are going to use. But it is important for you to know which method is effective, right, friends? So I think we are done with our today's session. That's good enough for today. And in the next session, we'll take some more numerical where we can use the unit load method in the upcoming week. And most probably I'll be there in the offline mode also, so we can do it together. Still, I'm not sure that the gadgets will be working properly at that time also, but we can try. We should try. We must try, right? So I'll be there in the class, and then we'll carry on with the session. Until then, keep practicing. Practice is very much required to improve your performance in the final examination also, because the way in which you have performed in this mid-sem exam is not at all accepted, right? So on this point, we'll also discuss few things during the offline classes also, or online classes also. Okay, so let's do it. And thank you for being with me, and stopping here today. Take care, enjoy the short break, and stay safe. We'll meet again in the next class. Thank you all.